Hey, hello everyone and welcome in a new video. In the previous video we have seen our practical exercise and today it's time for the solution. So let's go. So although of course we want to solve our DockerCoin exercise. So remember that we have this kind of architecture. So we are RNG, hasher, and a worker. This worker put some get on RNG and the post to hasher to have a hash value at the end, and after that the worker push the data inside the Redis, and yes, the web UI just interact with the Redis at the end. Let's go. Some element, yes, don't forget to make this exercise to read your Docker Compose, of course, and check the port, DNS and images, and to deploy each component you can choose directly the CLI, or you can use the dry run option for kubectl to generate all your services, all your manifest services and your manifest deployments, and edit it, of course. Today we just use directly the CLI. So we have our cluster here. I can create a little directory if I need, and let's go. So you can go directly inside the 24 Docker coins in Kate directory, okay, and inside it, and you have the link, of course you have the link inside the video description, and you can check here. We have all what we need. So of course if you want you can redo what we did in the previous video, so you can test again that you can run the DockerCoin inside Docker Compose. I provided you the images, so RNG, hasher, worker, and web UI and Redis. So this is all this image that we want to use. So the first thing that we need to do is to create a Redis, and if you want to create a Redis directly with the CLI, we can use kubectl create deploy for deployment, and Redis, this is the name of our Redis deployment, and after that -- image, and we want to use the latest version of Redis, so we can just put image equal Redis. So let's go. I can put it, and I can check kubectl get pod after that. That takes few seconds to download the image, and after that we can create our first service. And remember, yes, our first service. And remember, you can use two types of kubectl commands to create a service. You can use kubectl expose and the name, for example, of the object. So in this case, this is a deployment. The deployment is named Redis, so we want to set it to Redis. The service port set to 6379, and after that the target port, so to our Redis container, of course it's 63792. But you can use kubectl create service also, and create a service named Redis, and define the TCP connection. So in this case we want to use kubectl expose deploy Redis. So we can check kubectl, yes, we have our Redis, and we can check kubectl svc to check our service. Here it's our service. Now we have a DNS inside our cluster, and inside the default namespace we can use the DNS based on the name Redis. So you can use the DNS entry named Redis. So it's really easy, and this is exactly like what we did in our Docker Compose. You can check if the selector works, and to do that you can use kubectl get EP for endpoint. We can see also that for our Redis service we have our specific IP, and this is normally what we have for our Redis pod. Yes, we have the pod with the 0.4 IP, so it's okay. Now, after to define this Redis and to run this Redis, we can use kubectl create deploy to deploy RNG -- image and Preximo /RNG. So Preximo, don't take care about it. It's my user inside the Docker Hub, and you can use it, of course. So we can put it. And we can check that, okay, we download the image. And after that, of course, again, we can expose our RNG service. And to do that, we can use kubectl expose deploy for the deployment, RNG, the port of the service. So this is the port 80 because we are inside our cluster, and this is a cluster IP service, and we want to target the port of our container, and this is the port 82. So we can check, yes, it's okay. We can create this service, and of course we can create and we can check our service, so it's okay. Of course we need to do that because with Docker Compose we saw that we need to use the port 80 by default because we don't want to change anything in the default configuration, and this is special, but for the demo DockerCoin application, each configuration is directly defined inside the Docker image. So it's a bad practice, of course, and we will see that we can later change that with to test a config map, to test some change on services, but we will see that later. And we can check, of course, the IP here, and we can find our pod here, so it's okay. And now after RNG we can define the hasher. For the hasher again we can run hasher, and of course, like for the RNG, we need to set the target port to port 80 and the service port to 82. So yes, it's okay now. I can check kubectl get EP again, and it works. Don't take care about the order, because with DockerCoin, each component can retry and check if the dependency stuff work or not, and retry again and again. After that, we need to deploy the worker, and especially for the worker, we don't need to have a service. We haven't a service for it, so we can just run it like here and use kubectl get pod. Take a few seconds also to download the image, and it's okay now. Okay, and after that, yes, we need to have and we want to see our web UI, and to do that we need to create also a deployment again named web UI, and the image Preximo web UI. Okay, and at the end we need, but we have some specification for this service, especially for the web UI. We want to have a node port because we want to connect it inside our web browser, in our Debian or our laptop, and to do that we need to provide a specific port, and as we are inside our virtual server, we need to use the node port to expose on this server a specific port, a dynamic port, to expose this service. So we can check, so we have the web UI, it's okay, and we can check here the SVC, and you can see we expose the port 8000 on the port 30, so the port 30 333 for our virtual server. So normally on this port we have our web UI, and to check it, it's really easy to do that. We can use, for example, hostname dash I like this, and we can use our IP. So we can use this port. Okay, I need to, I can just go here, I put it here, and I use the port 30333, and yes, we have our web UI, and you can see that we mine some DockerCoin, so it seems to be okay. So after that, of course, we can use our kubectl scale command to scale what we have. So for example, we can use kubectl get pod, and we can scale the worker, because this is the worker who can if we take the architecture, yes, this one, this is the worker. If we scale the worker, we have more get to RNG, we have more post on Azure, and of course we edit more things inside the Redis. So our main component for the scaling is worker only. If you scale RNG, you won't change anything. If you scale the Azure, you won't change anything, and of course you don't, and it's forbidden to scale the Redis in this state here. And if you scale the web UI, this is not really interesting to scale it. Okay, so we can use kubectl scale, and what we want to scale, the deployment. The deployment is named worker. So you can see here the deployment, the ID of the replica set. Remember that we have already seen that, and the ID of the pod at the end. And for the worker, we want to use replicas, and we can set it, for example, to 30. And you can check again here, we have 30 pods, yes, it's cool. And that takes a few times to have it up and running, of course, but it's quick because we already have this image on it. So it seems to be good. And now we can go on our web UI to check that. Okay. And you can see we produce more and more DockerCoin. Okay, perfect. So we can scale down, of course. And for example, you can scale to 0. And with that, no worker, of course. And if you check kubectl get pod, no worker, because all pods are in terminating status. That takes a few seconds to shut down each pod. And after that, normally, we can see, and we will see, that our DockerCoin production just decrease a lot, and maybe shut down to 0. Yes, it's good. And you can see we have some errors because I think worker is not ready to just shut down with a kill on it. And yes, we are now our production is set to 0, and we can change again and pass to 1, and with 1, so kubectl get pod, it's okay. You can see here we have the normal production here. Okay, perfect. And if you want to remake and redo this exercise, you can do it with another example. And for example, you can use this kind of stuff. So you can create, for example, you can use kubectl create the deployment RNG, the image like we did, and you can use --dry run set to client -o set to YAML. We have already seen that, but it's really useful to generate our first manifest. So this is the deployment of our RNG, for example, and -YAML at the end, or YAML like this, and we can edit it. And we can change what we need to change. So the creation, we don't need to have it. The strategy, it's not really useful for today. The resources, not again. And this one, yes. And after that, you can also create the first service. So you can uninstall kubectl, delete pod, no, not here. kubectl get pod, kubectl delete deploy, and we want to delete the RNG, and we can kubectl apply the RNG deployment, like here, -f, yes, and it's okay. And after that, of course, we have a new deployment, but deploy with a manifest, and you can do the same thing for the kubectl SVC. You can remove the RNG SVC, and you can edit with a dry run a cluster IP service like this. Don't forget to use and to add the cluster IP. So this is the type of our service, and svc rng.yaml like this. We can edit the svc rng. We can remove that. We can also remove these lines, and it's okay, I think. And kubectl apply -f, and we have the svc rng. Is missing resource service annotation, which is required by yes, because I don't remove kubectl get svc. I need to remove, yes, I need to remove before the svc rng the service, the RNG service, yes, like this, and I can apply it, because we can change many things on service with a manifest if the service already exists. Okay, and after that, what you can do, you can, and maybe you can create directly a bash script to do that, but you can use deploy, and you can deploy another stuff, for example, the hasher, and vim edit the hasher, like that. And you can directly use semicolons, percentage s j, like that. And what we want to change all things named RNG, and we want to change that to hasher. So it's okay, I can apply it directly. kubectl apply -f deploy hasher, and yes, I need to delete the hasher before I forget that. Delete deploy hasher. Okay, that takes a few seconds, and we can apply it again. And after that, we can do the same thing for this the service, so svc, and we need to have hasher here, and we need to edit it, so the hasher, and we need to change it, so we can just redo the same thing like that. Yes, perfect. And we need just before to delete the service named hasher. Okay, and we can apply kubectl apply -f svc hasher, and it's okay. And don't forget that you can directly use dot to apply all files inside the demo directory, so it's really easy to do that. After that, you can do the same thing for the worker, so you can cp again on deploy named, for example, you can use hasher deploy the worker.yaml, and we want to edit the deploy worker.yaml, and we need, or we can just redo the same thing. We are on Azure here, so Azure, and we want to change Azure to worker, so it's okay, and we can apply it again with the dot directly. So I need to delete the deploy for the worker, so like that, and we can apply it again with the dot directly, and you can see no change on the other things, but a change specifically for the worker. And you can do all the stuff for each repository, each component, so it's really easy, and of course it works. It works here, so it's cool. Maybe yes, we need to delete so we have multiple workers during the period when we had a worker, the new worker and the previous worker in the same time, and now it's okay. That's it for today. Of course, you can delete all things, and to do that, you can use kubectl delete svc for example, and dash. So don't delete all things inside the default repository. Check before kubectl get svc, but you have a specific service here, and you don't want to remove the Kubernetes directory, so it's not difficult. Kubectl delete svc Azure, like this, the worker, no worker, not on the worker, RNG, the Redis, and also the web UI. Okay, and after that, for all pods, so we don't want to keep anything inside the pod, so you can use kubectl delete deploy, because we need to delete the deployment, not only the pod, and dash all to delete all deployment, so it's okay at the end of that. Okay, that's it for today. Thank you for following this video. Don't forget to subscribe to the channel to not miss the next one, and support me and with a simple like or comment, and see you in the next one. Bye bye.